Well, hello again everybody. So I've switched on this Stabiloc, this 4015, and I think I said to you last time I've not used it very often. I did buy it and initially I tried to use it and I found it quite confusing. And the reason I found it quite confusing, of course, is because I didn't read the manual. I never do. But I always complain about that. For example, the 2955, I've never read the manual for that, but I understand how to work it because it's obvious. Whereas a 4015 is a little bit more complicated. I guess I really need to read the manual. Well, in last week's episode of This and That, or TAT as I like to call it, you'll notice that I bought quite a lot of capacitors and things, and that was to recap this radio. I wasn't sure whether or not to recap it, but quite a lot of you have just told me to do it. I think Simon said do it, Scott, DefPom told me to do it, I think Andrew told me to do it, I think quite a few people told me to recap it. So I'm going to follow their advice and I'm going to recap that. But before I do it, I thought I should get some measurements before and after. Well, I've already got the FM quietening measurements for this, but what I just want to record is stuff like the transmitted power, what frequency it's on, maybe a synad value, just stuff like that, because then I can do a comparison of before and after. And also this radio hasn't been aligned, there's been no alignment carried out on this. So I thought we'd use the Stabiloc today just to try to get some of them measurements. So I'll just show you what we've got set up on the bench. So we've got the radio itself, the transceiver, we've got the RF connection that plugs straight into the 50 watt input on the Stabiloc onto the communications analyzer. We've got the external speaker connection that is being fed into the communication analyzer, and we've got this microphone input which allows us to inject an audio tone into the microphone input of the radio and do some testing. And today I'm going to be powering the radio from this TTI Furley Fander Instruments, and it's a linear power supply. So you can see if I put the radio into transmit, it's drawing 280 milliamps at the moment. If I actually just key it up, it draws, what's that? It draws about 900 milliamps. So the first test I'm going to do, I'm just going to look at measuring the transmitted power from the radio and see what frequency it's on. So first of all, let's have a look at the frequency we're transmitting on. Well, I've got the radio set to channel 20. So let me just look that up. Channel 20 on my crib sheet is... It says it actually should be 79 1.25 on channel 20, so actually that does look as though that frequency has actually dropped quite low. So I'm just going to abuse this little red thing down here until the frequency increases to about where we want it. Okay, so I'm on channel 20 at the moment, so I'm actually gunning for a frequency of 27.79125 megahertz, so let's have a go at that. It's fighting me all the way, this thing. It might be the actual alignment tool that I'm using isn't actually a very good fit. Okay, so I'm going to call that good at 27.79125, which is channel 20. Now on that screen we can also see the power level, so I'm going to make a note of that. It says it's 3.23 watts. Can you see that on the left hand scale? It says power, so 3.23 watts. So that's our transmitted power. Apart from the power meter, we've got this D-mod and this distortion meter. Well, the distortion meter is showing 1.9%. Again, don't really know whether that's good or bad, that's what it's showing. And I guess that's going to be related to the microphone, the input volume to the microphone on the radio, which is set here, which says 2 millivolts. So we're putting a 2 millivolt, 1 kilohertz sine wave into the microphone connection on the radio at the moment, and the radio is transmitting that back to the communication analyzer, which is analysing that and driving these meters. So I'm kind of thinking if we turn up the microphone level, I would have thought that, you see that says D-mod, but I'm wondering if that is just deviation. I'm guessing that it is deviation. So if we turn up the microphone level here, we shouldn't get an increase in deviation, and I suspect the distortion figure will probably also go up a bit as well. So let's just try increasing the microphone level. Okay, so the deviation did go up as we increased the microphone level, but it didn't appear to do anything ridiculous, so I'm guessing that this radio is quite well behaved in terms of its output deviation. I doubt that's splattering anywhere. because even when I turned up the microphone volume ridiculously high, it still only reached 2 kHz, and you could never reach that with a real microphone, I don't think. So let's just write those down. Demod or deviation 0.68 kHz and distortion 1.9. So for our next trick, I think we'll have a look at the receive performance. So again, playing it a bit blind here, let's choose receive, and let's have a quick look what's happening. So it looks as though the Stabilot, the communication analyzer, it's outputting now a frequency of 27.790 So that's a bit off frequency, because our radio should be set to channel 20, so that should be 79.125. And one thing I'm not sure about, I can't actually set that last digit. I don't know why, but I can't. So if anybody operates these Stabilots and they know why I can't set the last digit, I'll show you what I mean. So 27 point, and that should be now 79125, 7912. I can set the 2, but can I set the 5? Oh, it has let me set the 5. I didn't think it would do that, so I'm an idiot. Okay, 27.79125. Enter. It must just suppress the last digit for some reason. So I don't know if you can hear that tone there. That's actually the RF signal which is being picked up by our transceiver, and it's actually just coming out of the speaker connection and it's being connected back into the communication analyzer. So that's what you're hearing there. So the signal level that we're actually transmitting to the receiver, it's actually very low at the moment. It's minus 116 dBm. And if we actually look up that minus 116 dB on our little crib sheet here, it tells us it's 0.35 microvolts. So that's a pretty small signal. Now, I didn't show it previously on camera, but the reason I happen to have that minus 116 set there is because I was trying to turn the output level down to achieve 12 dB synad. And I've struggled to do that. It's basically just flicking around a lot, the needle's going up and down. I've actually had trouble doing synad readings. I've had trouble using, well, I'm struggling to get an accurate setting on this Stabilot. And to be honest, I've had about the same results using the Marconi. Whenever I try to set this 12 dB synad, it just seems to flick up and down. It wanders up and down by quite a large margin. So you see there, it's up at 16, 15 now. But it'll probably drop back down to 10, or it's back at 12 now, 14. It just flicks around, so I'm not sure why I'm getting that wandering synad. If some of you know what I'm doing wrong or how I can improve that, leave it in your comments, because maybe I'm doing something wrong, I haven't got something quite set up correctly. So if you can tell me what I'm doing wrong, that would be quite useful. So I've just been playing around with the analyzer, and I found that it does have some automated test functions. So rather than do it manually, perhaps we can run some of those automated tests. Bear in mind, I've not done this before, so system, well, it wasn't that button, you can tell I haven't done it before. System, is it special? Okay, so these are the tests here, so it will automatically go away and work out things like, it says it'll do synad, bandwidth, the AF response, and the squelch. I can guess what some of them things might do, but let's try it. So we've already took a manual measurement of the synad, and let's see if the automated test comes up with the same answer. So what we'll do is we just press run, I think, run. So although it might not look like it's doing anything, you can see there that the actual radio, is it increasing or reducing? Yeah, it's actually increasing the signal level, and I guess what it's trying to do, it's trying to measure when it reaches that 12 dBm point. Which is done. So it's actually come back as minus 16, which is actually the value I got when we did it longhand. But the fact that the needle wasn't flicking around everywhere, maybe the automated test is a better way of doing it. Maybe it does some averaging or something like that. So that worked. After that success, let's see if it'll tell us what the bandwidth of the receive is. So bandwidth. Okay, I'm guessing 3 dB. That would be right for a bandwidth, wouldn't it? The minus 3 dB point. Let's try running that. So I can see here it looks as though it's changing the output transmitted waveform, so it's changing the transmit frequency, and I guess it's measuring the returned audio power. Okay, and it's telling us here that this radio has got a 6 kilohertz bandwidth. Kind of wondering if that's a little bit higher than it should be. I think the channel spacing, maybe it's not bad. The channel spacing's 10 kilohertz on these CBs, so, and that's saying the bandwidth is 6.5. Again, not sure, I haven't got anything to compare it to. So the next one, let's try the AF response. So I guess what this is going to do, it's going to make the radio transmit a number of different tones, and then it's going to tell us here whether it's above or below the reference level, and the reference level is going to be 0 dBm at 1 kilohertz. So let's just try that. Oh, I quite like that. Did you hear that? Let's try it again. I'll turn the volume up a bit. So what that's showing us is the receive path on this radio. It's actually most sensitive to signals below 1 kilohertz. As you increase above 1 kilohertz, it rolls off. And I don't know if you noticed, the audio level that we could hear seemed to drop. Once it went above 3 kilohertz, you couldn't really read anything. Now I guess that's what you'd expect, because for speech transmission you can get all the information of speech in about the first 1.5 kilohertz. For music you'd want it to be 20 kilohertz, but this radio isn't designed for listening to music, it's designed for listening to speech. So I'm guessing that's what we'd expect. So we've got another one here, Squelch. Never tried that, so let's have a go at that. Just turn the volume down. So that has given us some information at the point at which the radio mutes and unmutes, and it's also telling us the difference between the two, which is that hysteresis there. So I'm guessing that minus 119 and minus 120, the difference is 1.2 dB. Not exactly sure what to make of that. I don't know what the squelch should break at or what it should be set to. Kind of not got that far with these CB radios yet, but again, we'll write all that information down and maybe use it when we do the alignment procedures or when we do our final checks. Now, I've said quite openly, this is the first time I've really played with CB, so I'm not exactly sure what measurements I should be getting, but my guess is that all those readings that I was seeing there are pretty much in the ballpark. There was nothing disastrous. It was a little bit off frequency to start with, but we managed to tweak that up quite quickly. So I'm kind of thinking that this radio is working fine, and I'm not sure whether or not we are going to get any improvement from realigning it. I guess it'd be nice to get the power output up to above, well, not above, but 2-4 watts. But certainly the receive sensitivity seems pretty good. The receiver bandwidth was at a little bit wide at 6 kilohertz. Probably would it have been better if it was closer to 5? Perhaps, not exactly sure. Perhaps people who are more familiar than me can leave it in the comments. So I'm going to go away now, and off camera I'm going to replace all the capacitors and tighten up all the screws, and quite likely this radio will never work again. So it'll then be a spares and repair, won't it, on eBay? Pass it on to the next person. So that's the plan, and I'll bring you back when I've done that. Well, the first part of the alignment procedure for this radio is just to set what I think is the VCO control output from, I think it's from the PLL chip. So what it tells you to do is you set the channel, you set the CB to channel 40 and you transmit, and then you monitor the output voltage on this test point here, and from memory I think it needs to be 2.5 volts. So I did that, and amazingly enough I was getting 0 volts. I went in and had a bit of a fiddle with this pot, and with this coil here, and by fiddling with that the only thing I actually managed to do was stop the radio from transmitting, because I'm assuming the PLL must have been losing lock when I adjusted this too far. That failed, and I had to do a little bit of digging then. I thought at first maybe it was something stupid like the pointy end of my test probe wasn't making it all the way through the circuit board to a copper pad to a solder pad on the bottom side of the board. I took the old leg of a resistor, cut it off pushed it through the board and soldered it on, and then I attached the voltmeter with a pair of crocodile clips, and again tried to align it again. Still getting 0 volts, and eventually I did actually figure out what was going on, and a bit of a bizarre one really. So I've got this diagram here that shows the copper pads, and it's got the component values marked on it in various locations. So you can see here's our test point 1, and here's the island, which the island of copper, the PCB tracking, which test point 1 is actually connected to. So you can see that test point 1, it shares this pad with a connection for resistor R157 and R158, and we've also got this little Hindenburg connected to it here, which is C208. Well, I've turned the radio over now, and here's our little copper island, and there's, you can see that little thing poking up through there that I'm pointing at. That's test point 1. But strangely enough, you can see here that the other holes in the island that should be filled with one with a capacitor and 2 resistors, well, there's the holes there, and but there's no components connected to it. So this test point is totally isolated, it's not connected to anything. You might think, well, you should have seen that immediately because you can see the holes there. Well, the reason you can see holes there is because I've desoldered them. I've sucked the solder off the top of them. They actually just look like any other pad. Maybe it was slightly obvious. I mean, it just looked like that pad there. When these were built at the factory, those components were never fitted. At some point in the history of this radio, and it would have been, I say the history of this radio, I mean this production run of this radio, somebody decided not to use this test point here, and they never populated it with components. It's never had components in it. That did stump me for a while. So what I had to do then was actually just find an alternative part on the PLL output chip. I had to find an alternative part to go probing. So once I did that, I managed to get the voltage levels that I wanted. So I didn't get exactly what it said in the manual, and it was very fiddly to adjust. Every time I touched it, it seemed to jump around a little bit wildly, but hopefully that's adjusted now. Well, I've gone ahead and done the alignment on the transmitter stage, and I've adjusted all the various coils. In fact, the only one I've got left to do is a final one, which reduces the output power, but I think it's also the harmonic filter for the output stage. So I've got to adjust that one. So let's just have a look at what we're transmitting. So turn the transmitter on, and we're doing 4.28 watts there, 4.07 watts. So the next thing to do is to set the FM deviation of the transmitter, and it tells us how to do that here. So we need to set the radio to channel 20. We need to connect a signal generator with 20 millivolts to the microphone input, and then we've got to adjust RV105 for 2.5 kilohertz deviation as shown on the deviation meter. So let's go ahead and do that. In fact, let's check what it is first. Well, I've gone ahead and I've adjusted the communications analyzer to give this 20 millivolts signal on the microphone. So let's turn the transmitter on now and see what the deviation is. Now, if anything, that looks a little bit low, doesn't it? So I'm just adjusting 105 now, and we're going for a deviation of 2.2 kilohertz. Gone past it slightly, just bring it back. Okay, so I'm going to call that 2.2, it's close enough. So that's the deviation set up with the microphone input of 20 millivolts, but I'm guessing I really should test it with a real microphone connected to the radio. So that's what I'm going to do. Wallow, wallow, wallow. Well, I suspect based on that test, if anything, my deviation level might be a little bit low, but because I don't know any better, I'm going to leave it set at that. It's certainly higher than it was when we started the procedure, so I guess that's a good thing. So the final thing I want to do is I just want to adjust the power meter so that when I key the microphone, we've got our 4 watts on there. So the display on here, the needle movement, it's not really very clear. The scale is compressed at one end, so it goes 2, 3, and then it goes between 3 and 5. So let's just key it up and see what it's adjusted to. and it's spot on between 3 and 5, so that doesn't require adjustment, so we'll leave that at that. That's good enough. So for me, that's the first time I've ever actually aligned the transmitter stage of a CB radio. In the past I've done it an awful lot with old valve radios and stuff like that, but I've never played with a CB, so I've found that, you know, it's been quite interesting, quite an education, and I hope you've enjoyed being with me at the bench today. A day at the bench is always a good day for me. I hope you enjoyed it too. But until next time, that'll do. Thanks for watching. Bye bye for now. Bye.